Someone is praying for you. Someone is praying for you. So when it seems you're all alone and your heart will break in two.
Hello, welcome to our lessons on ordinary differential equations. In our previous lesson, we looked at the characteristics equation of a higher order differential equation. In this lesson, you're going to take a look at how to solve higher order differential equation with constant coefficients. But let's consider the second and the third order homogeneous differential equations, 1 and 2. The characteristic equation for these two equations from our last studies are lambda squared plus p lambda plus equal to 0, and lambda cubed plus e lambda squared plus q lambda plus r equal to 0. Now to solve the equations 1 and 2, that's the characteristics equation. To solve equations 1 and 2, we solve the corresponding characteristics equation 3 and 4 respectively first. This polynomial equation in lambda can have three cases. First, whether the roots will be distinct but rare, repeated roots, or complex roots. Now, either of this is possible because we are dealing with polynomial, and for third and fourth order, we can have a mixture of the three. And they depend on whether the discriminant is positive for rare and distinct roots, 0 for repeated roots, and complex for negative roots. Okay, so we are going to take a look at the three cases. And the first case we want to take a look at when the characteristic equation has rare but distinct roots. So let's consider the second order homogeneous differential equation of this form, which has a characteristic equation of lambda squared plus p lambda plus c equal to 0. If we assume that the roots of this characteristic equations are lambda 1 and lambda 2, these are the roots, and they are rare and distinct, then the solutions are given by y1 is e raised to the power lambda 1x and y2 is given by e raised to the power lambda 2x. So this becomes the independent solutions. Now, by the principle of superposition, we can combine these two solutions using the linear combination of them. So the solution becomes c1y1 plus c2y2. And knowing that y1 is e raised to the power lambda 1x and y2 is raised to the power lambda 2x, you can write the solution as the general solution to be c1 e raised to the power lambda y1 lambda 1x plus c2 e raised to the power lambda 2x, where the c1 and c2 are constants. Similarly, for a third order homogeneous linear differential equations with characteristic equation lambda cubed plus lambda p lambda squared plus q lambda plus r equal to 0. If lambda 1, lambda 2 are the roots of the characteristic equation, then the independent solutions or fundamental solutions are y1 equal to e raised to the power lambda 1x, y2 e raised to the power lambda 2x, and y3 e raised to the power lambda 3x. And for that matter, the general solution is a linear combination of all the three. So let's start by taking a look at this example. You have to find the general solution for the square y by the x squared plus the y dx minus 2y equal to 0. We start by writing down the characteristics equation, which is, so the characteristics equation is lambda squared plus lambda minus 2 equal to 0. And we solve this characteristics equation. So lambda is negative 1 plus or minus the square root of 1 minus 4 into 1 into negative 2, the whole thing over 2. We want to use, what is a characteristics equation? That will give you a negative 1 plus or minus square root of 9 over 2. So it's either equal to negative 1 plus or minus 3 over 2, which means you have either 1 or negative 2. So these are the roots. So lambda 1 is 1 and lambda 2 is negative 2. And for that matter, the individual solutions are y1 e raised to the power x and y2 e raised to the power negative 2x. Hence, the general solution y of x is a linear combination of these two. That will be c1 e raised to the power x plus c2 e raised to the power negative 2x. So this is the general solution for this equation. Let's look at the second example. Solve the equation y double prime minus 7y prime plus 12y equal to 0 if the condition is y of 0 equal to 7 and y prime of 0 equal to 25. So we first start by looking at the characteristics equation. And the characteristics equation is given by lambda squared minus 7 lambda plus 12 equal to 0. And if you solve this, you're going to get lambda minus 3 multiplied by lambda minus 4 equal to 0. So you get lambda 1 equals to 3 and lambda 2 equal to 4. So therefore, the general solution is y of x equal to c1 e raised to the power 3x plus c2 e raised to the power 4x. So this is the general solution. We now begin by substituting the initial conditions. So the first one is y of 0 equal to 7. So if you substitute x equal to 0 to this, you're going to get y of 0 to be c1 plus c2 equal to 7. So we can have c1 plus c2 equal to 7 and call it equation 1. Then the second condition is a derivative. So we first take the derivative of this. So y prime of x is going to give a 3c1 e raised to the power 3x plus 3c2 plus 4c2 e raised to the power 4x. We then put in the initial condition y prime of 0. That will give a 3c1 plus 4c2 equals 25. So 3c1 plus 4c2 equals to 25. Then we get equation 2. Then we solve these two equations simultaneously. So c1 plus c2 equals to 7. 3c1 plus 4c2 equal to 25. When we solve them simultaneously, we get c1 to be 3 and c2 to be 4. So from there, we can now write our final solution that y of x equals to 3 e raised to the power 3x plus 4 e raised to the power 4x. Find the general solution of y triple prime plus 2y prime prime minus 5y prime minus 6y equal to 0. So this is a homogeneous equation, and the characteristics equation is lambda squared plus lambda cubed plus 2 lambda squared minus 5 lambda minus 6 equal to 0. And when you factorize this, you're going to get lambda plus 1, lambda minus 2, and then lambda plus 3 equal to 0. So the rules are lambda equals negative 1, 2, and then negative 3. Therefore, the general solution y of x is going to be c1 e raised to the power negative x plus c2 e raised to the power 2x plus c3 e raised to the power negative 3x. Let's look at another example, which is an IVP. Solve the IVP y to the fourth derivative minus 10 y double prime plus 9 equal to 0. Given that y of 0 is 10, y prime of 0 is 4, y prime of 0 is 67, and y triple prime of 0 is 28. So in the same manner, we look at the characteristics equation, that is lambda to the power of 4 minus 10 lambda squared plus 9 equal to 0. If you factorize this, you are going to get lambda plus or minus 1 times lambda plus or minus 3 equal to 0. And that means you are going to have lambda equals to 1 and negative 1, 3 and negative 3. So the general solution y of x is c1 e raised to the power negative x plus c2 e raised to the power x plus c3 e raised to the power negative x plus c4 e raised to the power, negative 3x plus c4 raised to the power 3x. So that is the general solution. Now we have some initial conditions. The first one is y of 0 is equal to 10. So here, when we put x equal to 0 in there, we're going to get c1 plus c2 plus c3 plus c4 equal to 10. We can call that one equation 1, because when x is 0, all this one will give us 1. Now the second condition is a derivative y prime of 0, which is equal to 4. So in that case, we also need to take the derivative of the general solution. So y prime of x is going to give us negative c1 e raised to the power negative x plus c2 e raised to the power x minus 3c3 e raised to the power negative 3x plus 3c4 e raised to the power 3x. So when you put in the boundary conditions, the initial condition y prime of 0 equal to 4, we're going to get negative c1 plus c2 minus 3c3 plus 3c4 equal to 4. So we can call this one equation 2. Then we have another initial condition, which is y double prime. That means you need to take the second derivative. So we go back and take the second derivative, y prime prime, because we are using this, and it's a double prime, so we need to do that. So that will give us c1 e raised to the power negative x plus c2 e raised to the power x plus 9c3 e raised to the power negative 3x plus 9c4 e raised to the power 3x. So when you put in the initial condition y double prime of 0 equal to 67, then we can say that c1 plus c2 plus 9c3 plus 9c4 equal to 64. And the last but not the least, we have the y triple prime equal to 28. That means you need to take the third derivative of this, and that y triple prime equal to negative c1 e raised to the power negative x plus c2 e raised to the power x plus minus 27 c3 e raised to the power negative 3x plus 27 c4 e raised to the power 3x. Now applying the initial condition, you're going to get negative c1 plus c2 minus 2c3 plus 27 minus 27c3 27c4 equal to 8. That will give us equation 4. And we solve this one simultaneously. We're going to get c1 equals to 1, c2 equals to 2, c3 equals to 3, and c4 equals to 4. So therefore, the particular solution is y of x, but e raised to the power negative x plus e raised to the power 2 e raised to the power x plus 3 e raised to the power negative 3x plus 4 e raised to the power